Welcome everyone. Now we are going to learn about instruction cycle. So what is the instruction cycle? Indeed, what it means. So let's explore this question mark that what is the meaning of the instruction cycle? Well, let me present you a diagram, and in this diagram we are going to see that why and what is the actual meaning of the instruction cycle. So there are three key components that I'm going to draw here. This one, then this one, and let's say this is the bigger one, and this one right here. Now, what are these? So let's name them. This is memory. This is memory. This is our processor. Processor. Okay. And this is our input output. Now, this is directly connected to this and this, and obviously this one is also connected. So these are interconnected things. Now, what is the instruction cycle? Well, in the instruction cycle, you need to understand just these three things. That's it. So we will be very clear about what is doing what. So input and output. What it do? Well, these are the devices that gives input. After processing we get output. So it's all about the input and output device. Like let's say, what are our input devices? Input devices, keyboard is an input device, and what is our output device? So our output device is monitor. Well, we can take other things too, but I don't want to question you. This is very basic thing, that what is input device, what is output device. Like a printer is an output device. It gives you out something. A mouse is the input device. You are pointing inside something. So like I'm having my pointer which I'm writing from. This is an input device from me, but the screen that is right in front of you, that is the output device. So this is all about the input and output. What else we have here? Well, processor. What a processor do? Well, we will be very clear about this one. Either processor processes processes instructions. That's it. That's all what it do. It processes the instruction. Like from your input device, when you give the command like 2 plus 3. So these are the two inputs that you gave with a command to add, right? So what actually going to happen? Processor is going to add them. So processor is going to add them and give you the result 5. So it processes the instruction, or you can say command. So this is what a processor do. Now it's time for the memory. What a memory do? Well, memory stores. That's the keyword here. Memory stores the data. Stores data. That's it. That's all what it do. We are very clear about this, and make sure there is no condition for any kind of the confusion in this one. Once we are clear with this, we will know the instruction cycle entirely. I mean it, entirely. Now, let's come back to this instruction cycle that we have. So, what happened? on this entire life cycle of the instruction. Let's take an example. Like I'm giving the input 1 and 3 and I want to add them. So what will first going to happen? The processor is going to take this thing. Now, do you think so this will going to happen? No. 1 and 3 will going to be get stored in the memory. 1 and 3. Then this positive or addition is going to happen. Now what is going to happen? Processor fetches this processor fetches these data and add them, and when the result come as 4 in our case, it's going to again store on the accumulator. Remember the accumulator? If this is A and this is B, so A is our accumulator, let's say. So we are going to keep update the value of 1 to 4. Now it will not be 1, the new value will be 4, and that's what is going to be displayed on our output device. So that's the instruction cycle. Well, let me write that also so that we can understand it in a more detailed manner. Well, in the basic computer, each instruction cycle consists of the following phases. So the phases of instruction cycle is as follows. Instruction cycle is follow. So let's see what it is. So first of all, it fetch an instruction from memory. Second, it decode the instruction. And then it read the effective address effective address from memory from memory if the instruction if the instruction has indirect address. Now the fourth point that we have here is execution. The most important thing is to execute the instruction that will finally lead us to our result. So these are the four fundamental things, and you can call them phase of instruction cycle. So first of all, it fetch an instruction from memory. Then it decode the instruction surely in the Boolean form in zeros and one. Now it read the effective address from the memory if the instruction has indirect address. Remember that implicit form, that thing. Execute the instruction. This is what going to happen in the phase of the instruction. Let's proceed and let's dig deeper into this concept. So now the thing that we're going to learn is fetch and decode. Well, how they work. So what is fetching and what is decoding. During fetch cycle, instruction is read. In the fetch cycle, when fetch is running, instruction is read from memory because everything is stored in the memory for sure. The address in PC, the address in PC is is moved to MAR, which is memory address register. Memory address register. The content is then moved. After that, once you gone through the memory, you just read the instruction, then the PC moved the memory location to the register. Now, what you will do when you reach to the register? Come on, answer me. What you are going to do when you reach to the address of the register? You are going to get the data. Yes, exactly. The content. That's what we mean with the content here. The content is then moved. Is then moved to MBR, from from which it is passed to IR, which is instruction register. This is our instruction register. PC is then incremented. PC is then incremented incremented by 1, or remember that plus plus thing, that's what I'm talking about here. Then the instruction is decoded. Then finally our instruction is decoded and executed. So that's what happened in the fetch and decode. First of all, fetch means taking the data from the memory and loads it in the processor. Now, the processor has to decode, like if I say to add, subtract, multiply or divide, it first has to understand that what it needs to do. For that, it has to decode the thing. So, first of all, it decode, and after decoding the content, first of all, the memory that it gets the data, and then instruction register that what to do, add, subtract, multiply, divide, whatever, and then it increment. Why it increment? To get the another value is required. Then the instruction is decoded, and finally it getting executed. So this is what happened in fetch and decode. In two simple words, fetch data from the memory to the processor, and that processor is going to decode and execute. That's it. That's all it. That's what it means technically right here in front of you. Okay, let's understand this same scenario with a block diagram. This is fetch, and here I'm making interrupt interrupt, then here we have say interrupt, and finally we have execute. Execute. So what is actually going to happen here? Let's understand with the arrow. After fetching, it has to execute, and after execute, it again has to fetch for the another data. This is related. After executing, it will interrupt because it's completed. After you complete something, you interrupt to do something more. And what the interrupt do? It activates the fetching cycle. And now fetching cycle will going to induct or command, and then it will going to execute. So the cycle can either be like this one that we are seeing, or it can go the way direct like here. In these cases, it's quite direct. Let me change the color so that I can highlight it. So this is the direct line, and second way is indirect. So ultimately, the fetch and decode is continuously happening. Like if I say x plus 1, I need to solve this and put the value in x. Well, in the computer science, it's written in this way: x is equal to x plus 1. Like say that this is my command, and the value of the x I want it to be 1, and then increment it till the point 5. Let's write it in not in this way, let's write it in this way: x and then 5. So this is what I gave as the condition. So what's going to happen now? First of all, the 1 is fetched from the memory, and now the value of the this gone to the processor, this gone to the processor, and now after processing it becomes 2. Now 2 will going to get incremented, and after getting incremented it will again going to fetch, and now 2 is going to fetch. So 2 plus 1, 3 is going to be our result, and now again it will fetch. So x become 4 plus 1, 5, 3 plus 1 actually, that will going to be 4, and after that it will fetch again and execute the instruction that will going to be 4 plus 1, which will going to be 5. So x is equals to 5, and then the loop will going to terminate. Now this is the kind of loop that I used here indirectly. I just not named it for loop, do while loop, or while loop and all that things. I just directly did it. So this is the way of doing it. I hope you have understood it quite clearly. So this is the way the fetch and execute cycle are actually working on. So with all that said, let's come to the last topic of this thing, the subroutine thing that we've started actually. So this is called as instruction formats. So what in the instruction format we actually have? Very simple, nothing is complicated in here. They can have 3 address instruction. I'm writing it shortly. 2 address instruction, 1 address instruction. That's all what it means. Now, 3 address instruction can be written as operand, and then we have higher um, byte address, byte address, and then we have lower byte address, lower byte address. So this is the 3 address instruction by which we are able to see that operand, higher byte, and lower byte. Now, what with the second thing we have? Well, second thing is going to be equally interesting. So let's come up to this one. And this we have opcode, opcode. Well, this is called as the operational code, and operand, O-P-E-R-A-N-D, or you can also call it as register. So this is 2, and this will gonna be for the third one, which is only gonna be opcode or operational code. That's what it means. Simple, right? These are the three instruction formats. Let's have a brief on this, starting from the one address instruction. Well, in the one address instruction, we require nothing special. In address instruction, only operation code, only operation code, operation code is required. Nothing else. We don't require anything else. That's it. So this is all for the one. Now for the second one, we are having two things. So we require 2 bytes, right? Great thing, right? So we require 2 bytes for this, and sometimes it carries immediate addressing mode. Okay, let me write that in the first page. So two addressing instruction that we are studying right now is actually one address of it is used for opcode or operation code, and one address space is used to define the register or operand directly. So that's all it. As you know that it's a code and register. That's what we are talking about. This is two address instruction. Two address instruction. So this is about the two address instruction thing. Now about the third instruction or third address instruction, I must say, it is having opcode, higher byte address, and lower byte address. Lower byte address. So this is what we are having. So this is our three address format, and this the first one is presenting, as we know, it's presenting operation code. So this is required, and we require this in all kind of the formats. So this is operation code. Now the second thing is address space. Address space. And finally, the third thing here that we have is it's address space instruction. Address space instruction. Address space instruction that direct. Let me write it here. Directing address. Directing address. Like addressing, if I may say, 16 byte. So this one is the factual thing. 16 byte immediate addressing is there. So this one seems more efficient or most efficient. Well, it is indeed. So this is all about it, and that's about three address format. So why we studied these formats? You might be wondering that why the instruction format is having three formats. Well, these three formats is going to tell us that how the things are going to work, how it's going to work. That's the most important thing, isn't it? So this is going to tell us that how the instruction is going and in which format it is going. Like it is only having opcode like in one instruction format, or opcode and operand, or kind of register that can register it, or the second instruction format, or the third instruction format that is having instruction execution and everything involved in it. So these are the three kind of things that we are having right now. So with this, we are ending up and wrapping up our instruction cycle. We learned fetch, decode, instruction cycle, and instruction format. With this particular portion is going to end up, and we will come up with a greater new thing in the next one. So till that time, take care, God bless, keep learning, keep growing, and have a nice time.